we have a much harder and different kind of algebraic manipulation problem. This time we're going to find the value of x squared minus y squared all squared. So what we can do with that, so we might play around with that later to help us find the answer. We have x and y that are real numbers such that x squared is not equal to y squared. What that means is that this is not equal to 0. If x cubed equals 17x plus 5y, and y cubed equals 5x plus 17y, that seems kind of symmetric. Find the value of x squared minus y squared all squared. And notice these symmetric-ish equations here. And also notice that it'd be very impractical to try to solve these. For example, if I move the 17x, and I can divide by 5, then I can plug this in. This is classic substitution. 5x plus 17 x cubed minus 17x over 5. What do we have here? We have an x cubed. So we have an equation that's something x to the 9th power. There's no way we're solving that. So there must be some other way to do this. So what that means is it's impractical to figure out the value of x and y and directly plug in. So then we look at what else can we make from this that might help us. Could we find x squared and y squared? That wouldn't really help much either because we have cubes here and we'd still have to solve for them to figure that out. What else do we notice? There is a square here, and inside we have a difference of squares. Let's see what happens if we factor out the difference of squares. X plus y, x minus y, it's all squared. Well, we know we can't find x and y individually, so perhaps we can find just x plus y and just x minus y. And this is where you should recognize something immediately. The way I remember these is that the x plus y term goes with x cubed plus y cubed. The x minus y term goes with x cubed minus y cubed. And there's always only one minus. If this doesn't have a minus, this middle one has a minus. And if this has a minus, this middle one doesn't have a minus. So we see we can get these from these cubes. We have the sum and difference. So let's try that. We have the sum 17x plus 5x, that's 22x. 5y plus 17y, that's 22y. And I'm going to go ahead and factor this with those sum of cubes formula. I see they're both 22, so let's just factor both of these as well. And we see that x plus y's cancel out. That's not what we were looking for. We kind of wanted x plus y and x minus y. But we see this x squared minus xy plus y squared. And that looks very, very similar to x minus y squared, which is x squared minus 2xy plus y squared. It's almost there, but not quite. And here we have another x minus y, so that might be useful. So then let's do the difference of cubes. X cubed minus y cubed. 17x minus 5x, that's 12x. We have 5y minus 17y, it's negative 12y. I'll go ahead and factor this. And then I'll factor the 12 as well. And we'll see that once again, x minus y is cancelled out. X squared plus xy plus y squared equals 12. Now notice, between this equation and this equation, the only thing that's different is this term right here. What's going on with that term? Well, we see from this thing, if we add 2xy, then we get this thing. What happens to the number? 22 goes down to 12, it's minus 10. So we have xy equals negative 5. So we can take x squared minus xy, subtract an xy. So we have 22. Now that we know this is negative 5, we can subtract off a negative 5. X squared minus 2xy plus y squared equals 27. And now we have the perfect square trinomial we need. And this is what we needed. If we take the square root of this, we get x minus y. But also notice that we are squaring them in the end. If we distribute this square out, x plus y squared x minus y squared. This is exactly what we arrived at here. This is 27. Now we can do the same thing on this side. We'll add xy, which means we're adding a negative 5. We can factor this. X squared plus 2xy plus y squared equals 7. And this is x plus y squared equals 7. And this is what we have here. So our answer must be 7 times 27, or 189.